So as I said, I'm Piotr Prus. I'm working at Tilt. It's an e-commerce startup, and today I would like to talk about managing hundreds of UI updates for Emoji Canon. So this is how it looks. This is something that I will share with you how I built that, and we'll go together through the code and see what are the challenges here. So as you can see, I have the fire button below at the bottom of the screen, and then whenever you click it, one of the random emojis are flowing on the screen, and after some time, they are disappearing. They're also rotating a little bit, and they have nice fade out animation. So all of this step by step will be introduced in that talk. So starting from very basics, to make such animation, we'll need a start point and end point for each emoji. And for starting point, I'm using here the local configuration current. And my starting point is screen width divided by 2, and also screen height 90%. So this is just rough example. So I didn't really calculate exactly where the button is, but it is somewhere there, and it works. So every emoji is coming from one place, the same point, which is somewhere around the bottom. An endpoint for each emoji lands somewhere at the top of the screen, where I'm using also the local configuration. This time I need the screen width and screen height, and I'm randomizing the int from 0 to maximum width, so the full width of my screen, and also randomizing my target y, which is from 0 to 20% of height. So every emoji ends their journey somewhere here. After that, I added also the rotation, as I said before. So this is just random from minus 90 degrees to 90 degrees, and also a fade out. So the fade out, I wanted to fade out the animation after a certain time. So in my launch effect, I'm running my opacity, offset Y, offset X, and rotation asynchronously. I'm awaiting all of them, and at the end, I'm animating the nice fade out animation. So every emoji, when it lands, it have few seconds, exactly 2 seconds, to fade out completely. So putting everything in the code, we have a simple box with a modifier. In this modifier, we have an offset, rotate, and alpha that change those parameters. And in the box, we have a text with the Unicode value of each emoji and the font size of 40 SP that just works fine here. And to put those emojis on the screen, I build a list, which is emojis variable mutable state list of my emoji, and my emoji is just data class with all those parameters. Okay, it looks like I'm back. I don't know what happened. My internet is fine. So every time user click fire, we are adding a new emoji data class to our list, and that's it. Where are my slides? Here. Okay. So then with this list, I'm calling list for each, and for each emoji, I'm displaying my single emoji container that have this offset and box as I showed you before. So everything looks good. Now, basically, our work is done, right? Everything works smoothly. We could end the work here, but let's check what could go wrong. So if you go to recomposition count in the layout inspector, you will see that every time we click fire, the recomposition count goes really wild. In this case, into almost 300 recompositions for every single emoji. And this is unfortunate, because if you are firing just one or two emojis, maybe that will not cause a lot of issues. But if you are firing thousands of them, it will freeze eventually. So what can we do with that? How we can managing these recompositions? So there is a really nice article by Ben Trumgrove, Jetpack Compose debugging recomposition. And basically from this article, what you can take is that for every frequent change preference to your composable, you should prefer lambda modifiers when using frequent changing state. So in our case, the offset function that we have here, rotate and alpha, can be changed to offset lambda function. And now we are just introducing int offset and providing the x and y value. And then for rotation, it's a little bit more tricky because for rotate, we do not have the lambda function. But there is another function which calls graphics layer. And this graphic layer have the rotation z and rotation x and rotation y parameters that we can change. So since this is in lambda, it will not cause additional recomposition every time rotation is changing. And for alpha, we'll use exactly the same trick, which is just putting these things in graphics layer. So let's check our recomposition count now. Every time user click fire, our recomposition is just 1. So everything works as expected. But as you can see on the screen, after I hit the button 5 times, all those emojis disappeared after some time, but they are still somehow in the memory, in the screen. You can see those little gray boxes at the place where emoji were positioned. So they are still in the compose. They are still in the calculation for all the views that are in the screen. So if I will fire 10,000 emojis and all of them will stay on the screen and be just ghosted, some weird things will happen. So I skip it 700 frames. I got this weird error, delay of duration 12,000 milliseconds. And my background concurrent copy is paused for 12 seconds. So basically my app is freezing after firing a lot of emojis. And when we will see the memory footage from Android Profiler, you can see that the memory is just increasing. So here you can see the memory footage from firing those 10,000 emojis. And the memory is increasing to 250 megabytes, and it's never decreasing. So all those emojis, even they are not on the screen, they are still in the memory. As you can see here at the start, we have like 100 megabytes, and then at the end we have 250. So all those invisible items are causing this. And how can we do this? We can just simply remove that from the list. So to remove that from the list, I'm just calling on animation finished in my launched effect after all the animations are finished. And then in my single emoji container, I have this high order function on animation finished, and I'm calling my emojis list, and I'm removing one emoji one by one. And here's the effect. Firing some emojis, they are disappearing, and what is going on? Those emojis are changing Unicodes during the recompositions. And why we have those recompositions? What is actually happening? So the emoji list is edited during the animation. So all the elements are recomposed. it switches the emoji every time we call remove from our list. But this is cool, right? All the clients would love to see such animation. We do not have any memory issues anymore. We just have some weird animation, but maybe it's cool. If you would like to fix that, you need to inform the view to do not recompose children when list is modified. And to do that, we can use the key utility function. And what is this key utility function? So it's a utility composable that is used to group or key a block of execution inside of the composition. In other words, whenever you're putting a key and then in your block your composable, if this key is not changing, your composable block will not be recomposed. So that is why in my data class, I added the ID, which is just a string. And to randomize it and have it unique, I'm just using UUID, random UID to string. So every emoji that appears on the screen has unique ID. And now on my for each function, and I'm wrapping my single emoji container into this key utility function with my emoji ID. So every time I will remove it from the screen, the list will not recompose every other element because every element has unique UID, and the compose knows to do not recompose it since the key didn't change. And actually, the same thing is used for lazy column, lazy list, exactly the same mechanism. It's called differently, but underneath it's a key function. So now we can see our memory graph and also the layout inspector. As you can see, whenever we are removing the item from the list, they are disappearing. They are disappearing from the layout inspector. So we do not have those ghost emojis. We do not also have this weird behavior in our video, and also our memory drops. So now when we had, I couldn't really reach more than 130 megabytes because every time emoji disappears after a few seconds, so I couldn't put like 10,000 of them. But during the animation, during the application running, you can see that memory is dropping, and at the end we are landing somewhere around 100 megabytes, which is our initial value for memory. So everything works good. Now I would like to show you how we are using that on production. So at Tilt, you can send a reaction during the live stream to the room, to the streaming room, to another user. We are sending that to the backend as our user emoji. And backend is sending that back to all the users that are currently watching the stream as a viewer emoji. And we are displaying that on the left or right side of the screen with a little bit of alpha to do not disturb the viewer experience. Then another user can also send another emoji, which is our user emoji, and backend will do the same thing and show us this as a viewer emoji. So in our view model, we have the mutable state flow, and we have a set of pairs. And one string represents the unique ID, and the second string represents the Unicode for the emoji that is sent. And our viewer's reaction is just a state flow of this set. Then in the view model, we also have the function update viewer's reaction, which is giving this pair that will just update the list and remove this pair from our viewers' reactions. And in the composable, as you can see, I'm using exactly the same thing, which is viewers' reaction for each. And then I have this key utility function and I have my room viewers emoji reaction, and I'm putting here my emoji pair first is Unicode, and then I have my path randomizer and modifier, and on animation finish, I'm calling my view model function. And here is this production example. So as you can see, this is a room that is scheduled, and there are some users that are currently sending the reactions that are just flowing from left and right on the screen. But as a user, you can also choose one of the emojis from our emoji bar and put it on the screen, so other viewers will see it as well. So the key takeaways from this talk: use Lambda versions of modifiers when your parameters are changing a lot. Use the key utility function for the things that you do not want to recompose if the key didn't change. Always check your number of recompositions. I was really in shock that every one emoji was causing 300 recompositions. And remove the object from the state, even if they are no longer visible, because as you saw, the memory is not cleared correctly. And as a bonus, I can share with you that using this technique, I'm currently building the particle emitter, and I'm sharing news about it on my Twitter account, so you can see how it goes. I will probably open source it somewhere at the end of the year, because currently it's all around composable, but I'm also exploring how to do it with Canvas, so it will display more composables, more items on the screen. So since it is composable currently, you can do a lot of nice things like this blur effect on the 4th screen, or those flare effects on the 5th and 6th, because every element on the screen is composable, so you can add there whatever you want. You could flow the box or the column or the text or the image, and Canvas has its limitations. Thank you so much for listening, and if you have any questions, just give me a comment.
Thanks so much for that. It was a really great talk. Yeah, as mentioned, like if anyone has any questions, feel free to drop those in the chat, and we'll talk about those. One that I did have throughout the presentation was I was curious like why the Lambda modifiers are so much more performant in terms of recomposition than the other version.
That's a good question. So you can learn more on this article that I shared, debugging the view, debugging the composable, something like that. You will have more info there. But basically, what is happening is that every time your normal parenthesis modifier changes value, all the modifier 3 are changing. So one of your child in the tree is changing. So all the tree is recomposing. It's just basically the composable is creating the new modifier 3 every time the normal parenthesis parameter changes. So that's why it causes recomposition, and for Lambda, it's not causing recomposition.
Okay, yeah, that makes sense. Sort of like exponentially, the more things that are added there.
Yeah. One more thing I just remember, if you would like to read about all of this that I just shared, I have the article on my Medium account that I will share right now in the comments. That is basically the same thing as this presentation, but as an article. So you can read it Oh, I cannot share it. Colin, I will send you in private message and maybe you can add it to the chat.
Sure.
I would need to log into YouTube to add it, so I'm not prepared.
Sure. Yeah, I can send that in just after.
All right.
Cool.
No questions?
No other questions, it looks like. Yeah, so thank you again for sharing the talk. That was great.
Thank you so much. And have a good rest of the day or night, whatever your time zone is.
Yeah, you as well.
Yeah, see ya.
See you, everyone.